Let me start the slideshow. And let me get out my pen. Okay. Today actually we'll be doing a smoke control, but mostly we will concentrate in Atrium. How do you design smoke control for Atrium? Which actually you can use also for rooms. When you are doing rooms only, you want to extract smoke from the rooms, you can also use that. But actually I use Atrium as an example. All this we focus on Atrium because in Atrium there are many aspects that you need to take into consideration. Design can be quite complicated. So we'll focus on Atrium, and then from Atrium, all these things you all can adopt what I presented. We also have a workshop session with spreadsheets, and then you can apply it even to your rooms. Let's say you have a very large rooms, more than 1,000 meter square. You may need to actually do a smoke control in the room. So here, okay, we can see it's actually an atrium. This is where the fire is. So actually the fire is from the room. Let's say this is a room of origin. You can see that it's actually spilling into the atrium. There are actually many scenarios. Actually the fire can be actually from adjacent room. It can also be actually situated inside the atrium, but the way actually you do the calculation is different. But you cannot actually say that the fire must start inside the atrium unless, of course, you have walls all over. But if you don't have walls all over, you cannot say that the fire must start in the atrium. You need to consider, do two considerations. One is fire inside the atrium, and one is fire in the room that is adjacent to the atrium with openings to the atrium that the smoke can actually spill to the atrium. Unless, of course, you want to extract the smoke from the room. So if you are not extracting the smoke from the room, the smoke actually is actually will spill into the atrium. Then you need to consider that also. And then between the two scenarios, you think you actually work out which one actually is the determining factor. So which one actually requires a higher extraction rate, whether it's actually fire in the atrium, inside the atrium, or fire in the room that is adjacent to the atrium. So we will actually use BS7346 for the open. We'll concentrate on open atrium. For the closed atrium and sterile tubes, all these things, maybe you want to adopt the UBBL. UBBL have got fixed air changes for closed atrium or sterile tube atrium. We'll go in detail in the definition of atriums a bit later. So this presentation is to introduce the concept of smoke control. So before you start to design your smoke control, before you go and do your calculations, everything, don't get excited. The first thing you have to ask yourself, what's your design objective? So actually in smoke control, generally there are three objectives. One is actually for life safety objective. So that means this life safety objective means that you actually control the smoke such that it will not impede the people trying to escape. If somebody is trying to escape, the smoke must be kept above his head or her head so that he or she can actually see. It's visible where she's going to. She can find the escape route, then she can actually escape from the building. So the second objective, so let's say in a warehouse, you may no longer want to do for life safety. Let's say there is nobody in the place, all these things. So maybe you may want to do property protection. So property protection, all these things, there's different ways of doing the calculation. So actually, most of the time is that in a fire, your property is not damaged actually by the direct impact of the fire. That means your property burning, all these things, most of the time actually is due to two kind of damages. One is actually the smoke block. That means, let's say if there's a fire, all these things, like in a hotel room, all this, sometimes the furnitures are not like that damaged, but then it's like there's in the sense that it's burned, but because there is a smoke block, so everything smells of smoke, all these things. So you may have to wait for time to clear, for the smoke smell to go off. So for property protection, let's say if you are in a warehouse or these things, then maybe you want to keep the temperature of the smoke to a certain temperature that actually your properties can withstand that temperature. So those are the thing. Or maybe you want to keep the smoke level. But let's say if the thing is cannot withstand smoke, you don't want any smoke damage apart from heat damage, then you keep the smoke above the property level. So those are the things that you can do, all these things. And then number 3 is firefighter access. So firefighter access, you need to discuss with the firefighters that they need to get access to the building, all these things. So what is their requirement? What is the minimum height for the firefighter to go in? Minimum height of the smoke base layer, how you want to design that, so that you need to talk to the firefighter. Or what is the temperature control you need to apply, all this you need to talk to the firefighter. But a lot of times all these things, I think this access, all these things is more or less, it's like if like your building is sprinkler protected, it's more or less is for the firefighters to mop up. So things like your sprinkler is expected to actually activate, supposed to control the fire. And after that, the firefighter will go in actually to that means the fire is not like growing at very big rate. It's actually a steady, you control the fire. Or then the firefighter will come up to mop up the fire, so to make sure that the fire will not reignite. So this is the meaning of a firefighter access. So a lot of car parks, all these things, when you said fixed air changes, you want to design a fixed air changes, fixed extraction. Let's say you want to design for 10 air changes. There is no actually scientific reason in the sense that why it must be 10 air changes or 12 air changes, unless of course what you are designing for is not life safety, is more like to make sure that you are diluting. Let's say there's already a fire, then the fire is under control, you mop up all these things, and then you are diluting the smoke so that it's easy for firefighters to go in. So I noticed that in Malaysia a lot of time that we do like the fixed air changes in car park. So that is also actually in the BS standard. BS standard also, I think there is also fixed air changes in car park. But the logic behind, I'm not too sure, because it actually does not really help so much for people to escape when it's fixed air changes, to escape from the building. So what's the learning objective of the course? So let me go through the learning objective of the course. First is that we need to learn how to assign different objectives or criteria. So you need to pick what is your design objective. Then after that, before you go further, all these things, your design actually is very much dependent on the configuration of your atrium. So how is your atrium, whether it's closed atrium, sterile tube atrium, or maybe it's an open atrium, then you need to actually define the atrium. And then with different atrium configuration, there will be different applicable control methods. But the one that is most stringent and challenging is the open atrium. So we'll concentrate on open atrium. So the design input and criteria for open atrium we'll go through. And after that, once we have our design input, we know that what we want to design to, what we want to achieve for these things. Then we can use your design input to calculate our mass flow rate. Once we have the mass flow rate, then we have the density. Let's say we have the density, we know that the temperature of the smoke, we can calculate that. Then we can actually calculate the volume flow rate for fire. So volume flow rate, there are two criteria to calculate. One is for fire inside the atrium. Let's say your configuration is open, in that sense, kind of like open. So one is you design for fire inside the atrium, and one is in the adjacent room. So you see which one is actually the criteria, which one actually is the more demanding criteria. So in Malaysia, I find that the guide to fire protection Malaysia is kind of strange, because we only consider fire inside atrium. But actually, if you check the BS standard, it's not only BS standard, even if you check the NFPA standard and you check SFPE, all these things are recommendation, we always need to consider the fire in the adjacent room. So we will go through that, all these things. It's like, I think it's better off like for open atrium, either we follow the BS standard or we follow the SFPE or NFPA method, NFPA 92. But here we'll concentrate on the BS standard. And in our spreadsheet, actually, we have developed in the BS standard. Actually, I have two spreadsheets. One I do is for BS standard. One I use SFPE, which is actually using NFPA 92. So, but I'm not sure whether I got the time. If I got the time, all these things, I will share also the spreadsheet for SFPE. So the next thing, once you calculate the mass flow rate, you don't stop. You know that your volume flow rate, but you cannot be extracting everything at one point. Because if you extract everything at one point, the velocity will be very high. And then you got a phenomena that's called plug holing. So your extraction now is not stable. So this will go a bit into detail. What is plug holing? How do you calculate the critical velocity of extraction? From the critical velocity of extraction, then you know how many extraction points you have. So even if you want to calculate using like CFD, CFAS, all these things, softwares, all these things, it's good to actually do a pre-calculation here, all these things, and then actually you simulate it using the number of extractions that you've decided and the volume of extractions, and then you put in your design fire, and then you see what happens to your smoke, whether actually your smoke level will get too low, whether it's acceptable. Then the other thing is that was never really addressed in the book Guide to Fire Protection Malaysia is there's a minimum depth of the smoke reservoir. So if the depth of the smoke reservoir, all these things is not there, all these things, then the smoke may actually like not be buoyant. You may actually like cool off quite fast and it drop. So we will actually calculate the minimum depth of smoke reservoir. If we cannot achieve the minimum depth, then we need to change a certain design input. So we go back to here again. Then the last part, actually, we'll have the brief introduction is another method to use the pressurization method to control smoke. So I have actually covered the introduction. Now I'm going into part 1. So actually I will stop my recording now.